Welcome to the Chief Strategy Officer Podcast. This podcast and Outthinkers Peer Network provide a platform for the architects of corporate success, Chief Strategy Officers, to collaborate and share their unique experiences in tackling complex challenges, navigating disruptive technologies, and driving impactful growth. If this speaks to you, join us at outthinker.com. In today's episode, we speak with Oreste Donzella, former Chief Strategy Officer of KLA, a global leader in semiconductor process control and inspection. Oreste brings over 3 decades of experience in the semiconductor industry, a sector that quietly powers every technological advance we see today. You know, every strategist is planning for their company's AI future and charting the course on assumptions about computational power, cost curves, and technological capability. But few are examining the foundation on which all of that rests: semiconductors. Oreste is a veteran strategy officer with decades navigating the complex semiconductor stack, and here we explore the dynamic shaping foundational technologies, from manufacturing processes to geopolitical tensions, so you can better anticipate the forces that will enable or constrain your AI ambitions. In this episode, we get into why AI's rise is really a story about semiconductors and how the industry's emotional revenge, as he calls it, is unfolding. The hidden complexity of the semiconductor supply chain and how a few specialized companies shape global innovation. The movement towards modular, heterogeneous chip design and what it means for strategy leaders in every sector. Oreste's perspective reminds us that strategy doesn't live in isolation. It operates often within vast, interconnected systems. And those able to think at the system level, able to understand how they are evolving, will be the ones able to understand where value is truly pooling and therefore where to play. Let's dive in with Oreste Donzella. Oreste, it is so great to have you on. Thank you for being here with us. Where are you joining us from?
I'm joining from Los Angeles today, my primary residence. This is where I am this week, but this is just by chance because I travel so much.
Where else do you travel to? Where else are you spending time?
In the new journey that I'm taking my career now, I'm a board member. I'm an advisor for various companies in the tech space. And I work either out of my primary residence in Los Angeles, or I work out of Silicon Valley, where, of course, the tech space is the center of the universe. And then I have a flat in London where I pretty much travel through Europe, where I have some of my contracts.
Yeah, great. So we're thrilled to have you on, in part because I feel like, and you would know this better than I do, but I kind of feel like a lot of the talk about AI is assuming a foundation that we don't really know much about. You know, I think of it almost like the Wizard of Oz, right? Like there is this thing going on in front of the stage, but we don't know what's going on behind the curtain. But, you know, you bring such experience on that foundational level of the semiconductors that are enabling or limiting what AI can actually do. What is something that executives and strategists that are really looking at that software human interface level, what's something that they don't appreciate about how the semiconductor foundational layer might limit what AI can actually do?
Yeah, and what actually no limit, but also enable what AI can do.
Great point.
If you think about it, AI has been in the work for decades. So AI seems to have exploded in 2022 when there was the famous announcement of ChatGPT. But in reality, they've been in work for, 40, 50 years, from the Turing machine after the Second World War. And eventually, what it really enabled the last wave, the incredible explosion of AI in the last couple of days, and it will continue for next several years, is because now you have a compute that give you the possibility to train these large language model. You have the possibility to get access to data from the internet. If you have a possibility to store this data, to analyze the data, to communicate and transmit the data. But if you think about all this, semiconductor is really, really at the center of all. And for a person like me that has been in the semiconductor industry for all the career, so I started end of 1992, I got my master's degree in electrical engineering. My first job was a process engineer in a semiconductor fab. For me, it's been like a sort of emotional revenge because for 25 years, nobody cared.
I love that emotional revenge. I love
Exactly. Semiconductor was, oh, semiconductor chips. What is that? People confuse the chips with potatoes. But in reality, people didn't really have a great appreciation of what the semiconductor industry was giving to the world. And these starting to get more and more visible. First of all, because the world was coming to an end with COVID, we didn't know how to react with the massive supply chain destruction. And eventually, semiconductor was seen like the most precious, the golden device that could move everything because of the huge demand in the COVID period, the post-COVID period, and then people started to realize how important semiconductor is. And this is the first time. And the second time was AI. And we cannot make enough semiconductor. We cannot package enough semiconductor devices just pretty much to catch up with the incredible demand coming from artificial intelligence that is mostly training this large language model.
Yes.
But I believe there is still a lack of appreciation how complex building these semiconductor devices is all around the world. And first of all, the capital that is needed is incredible to make sure that you have at the right time, in the right place, the right device to catch up with the demand from AI.
Just to help us understand what the dynamics are. So we've got really high capital, CapEx requirements, assume really high entry barriers because of that. I'm guessing it's sort of like maybe an oligopoly that's fairly like vertically integrated with large players with few customers, or how would you characterize it?
Yeah, so let me classify all the layers of a semiconductor.
Yeah, that would be very helpful.
So at the top, there are the people who require semiconductor devices. As you know, semiconductor is feeding many industries, from automotive, from data center, from smartphone, from PC, from industrial, from medical. Semiconductor devices are pervasive in every single industry in the world.
That's a great point, because I think that when people think semiconductor, they think primarily PC and servers, but that's a great point. Thanks for pointing that out.
It used to be.
Right.
And then semiconductor industry started like 6+ years ago. But that time was mostly for the aerospace and the military type of applications. Then the PC started to become a reality not only for corporations, but also for individual users like you and me. Then there was another big revolution, was internet. In the late 90s, of course, we figured out there is a possibility to communicate, to connect all the computers together. And if you look at the semiconductor, it was mostly dedicated to serve the internet space. And then with internet came, of course, many applications. Probably the most famous of all is the smartphone.
Yeah.
And then the semiconductor industry was driven mostly by smartphone demand. So you saw this evolution decade after decade of a single user that was driving most of the demand of semiconductor. Now it's not the case anymore. So even if we say AI is the biggest user, but AI is pretty much spread in every single industry that you can imagine. So the demand now is coming from multiple industries. That means the end demand is more diversified. The pervasiveness of semiconductor is way larger. And the good news for us operating in semiconductor industries, we see less volatility of the semiconductor industry. That was one of the biggest concern that the people like PEs or investment banks had for many years in investing in semiconductors. Okay, I can invest, but it's too simple.
Right, because when you have a concentration with a few buyers, then you have greater variability, greater cyclicality. Now, a semiconductor company is selling to many buyers that are making devices, and as you said, in medical devices and automobiles, and so that diversifies the cyclicality. And then that then increases the valuation of semiconductor companies.
It's exactly that.
A tangential question on NVIDIA. My very basic understanding is they had a chip for graphics cards, and then they figured out that could be the perfect kind of technology for the type of compute power that would be needed for AI. How much of it was luck and how much of that was foresight?
I don't believe it's luck at all. I think Jensen Huang and NVIDIA executive management had this, I don't want to say plan because it's very, very hard to make a plan that is going to materialize after 30 years, but they have like a vision using pretty much compute based not only on words, but on graphs and images and so on, could lead to something really important in the future. They couldn't find the AI world 20 years ago, 30 years ago, or 15 years ago because there was an infrastructure. Remember, AI is there because the semiconductor compute became very, 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 very powerful. Second is there is an infrastructure that is internet that is giving you the possibility to access to data to train this model. And the third is there are data centers where you have the possibility to train the large language model because the vast amount of computing power that you have stored in the data center right now. So I think NVIDIA figuring out a long, long time ago that having the possibility to compute based on image is going to lead to something that can create pretty much an artificial intelligence reality in the future. They didn't know when, and eventually happened when the infrastructure was built.
Got it. This is fascinating, especially if I think of myself maybe as an investor, just a student of the technology, but to break this relevant to people that are building the devices, the apps on top of the devices, building the ancillary businesses around the apps on the devices. Maybe could you bring to life for us something that people think they will be able to do, but they may not be able to do because of the hardware limits, or as you said, something that they're not thinking that they can do, but actually they can do because of the abilities of hardware?
I believe the semiconductor technology is extremely, extremely complex. We were talking about the layer of the semiconductor industry. We stopped to the top, that was really the NDML. But let me go down now in the stack. I'll tell you what we can enable and what is mostly the limiting factor in the next foreseeable future. So first of all, at the top, I said there is really the people buying semiconductor device from NVIDIA. Then we go down one level. There are many, many semiconductor devices you can pick. In a very simple way, you can split these devices in very advanced computing chips. And these are the GPU that NVIDIA is designing and selling, or the CPU, the central processing units that are coming to data center, or the PC or server, or the application processors that are in our smartphones. So these are really what we call advanced logic. So advanced compute. And of course, I'm simplifying here. There are many, many different advanced logic chips.
Understood.
And then there are memory. There are different memory types. But memory are very important because not only you need to store the information, but you may also have the possibility to communicate with the processor because the processor needs data in real time. And this incredible communication that is happening in incredible, the speed of light type of throughput. So it makes really the magic in a data center because the connection between the memory and the compute needs to be super, super, super tight. And then there are the less advanced logic. For example, in electrical vehicles, you need to power the motor. That is not that advanced in terms of the technology produced, but there's a lot of complexity. So you can picture this. Okay, I have advanced logic, I have the memory, and I have the trailing edge logic. And there are multiple companies working in these three segments. But when you go to the advanced logic, when you go to who is capable for building the chips that NVIDIA is designing, there are no many companies. So in that space, the supply of semiconductor devices is very, very narrow. Is mostly, I don't want to say dominated, but the big player is, as you may know, is TSMC. The Taiwanese company that we call foundry because they don't design their chip, just produce the chip for whoever is designing.
I gotcha.
There is TSMC, there is Intel, Samsung, and that's it. These are all three companies that can make these incredibly sophisticated computing, advanced logic.
Fascinating.
Memory also is very, very consolidated, especially on the DRAM side, the dynamic random access memory, that are the memory devices.
Mhm.
And there are three major DRAM makers in the world, one in US and two in Korea. So you can see the industry of making semiconductor devices is very, very consolidated. And then in order to make these semiconductor devices, you need the material. Now, this is where I come from. In my experience, I worked 25 plus years. My last job was in KLA Corporation. It is one of the top 5 suppliers of equipment to make and test semiconductors.
Mhm.
Building these products is extremely, extremely complicated.
Interesting.
And eventually, it costs a lot of money in research and development, and also building this complex equipment costs a lot of money. So that's the reason why, when I said before, you need a lot of capital.
Yeah, so I see we see this proliferation of players at the top of the stack and beyond the end users. But what is shocking to me is how specialized and how few companies there are that we're building this dynamic industries on these foundations that are very, I would say, very stiff, maybe. And now we throw into that this global competition, the economic uncertainty, this polarization. Generally, how do you see national strategies reshaping the industry over the next decade?
Yeah, this is a great lead, actually. I started in 1992, and I remember when we were probably in the mid 90s, probably 95, 96, the semiconductor industry, remember, bases all the success on the technology roadmap. So we needed to make sure that every 2 years, every 18 months, pretty much the semiconductor industry can scale to the next that we call technology node. That means packing more transistors in the same area of silicon. But what is limiting or may limit in the future? And there are two things. One is, and this is incredible to say, it's power.
Power, I see.
You know very well that because there is a lot going on in saying, we need a nuclear power facility just to power up the chips in a data center. What's going on here? And the level of energy that is massive data centers that are full of servers, full of computing chips inside, is consuming right now is incredibly high.
Yep.
So the industry overall, the semiconductor industry, that has been incredibly successful to give the world all the compute power they need, also to train a very large language model right now in AI, now gotta figure it out how you can improve and increase the computing performance, making sure that you keep the power and the energy consumption under control. Now, of course, the power energy efficiency is very important when you want to build chips for a smartphone. But now this complexity is exponentially growing when you see these enormous data centers that consume a lot of power, like, we need a nuclear power station just to feed the chips in the data center.
Yeah.
So this is one limiting factor. Now I go back to your last question, geopolitics.
Yeah.
So what is happening in the world? Okay, we had this COVID period with the shortage of chips that people say, oh my God, this is incredibly important. So the governments never paid really big attention in the last 10, 15 years before COVID to semiconductor industry because it was all about consumer. But now it's become so pervasive that it can shut down the world. I don't have chips in my hospitals, and my machine, my technology that is giving you the possibility to have better healthcare are stopping.
Yes.
So the government started paying attention. Then there is, of course, the AI. And the AI is extremely sensitive because, of course, with AI, everything is a semiconductor control. So it's becoming very, very important from a military, from defense point of view. That means the governments are getting even more careful And then on top of that, there are two wars, at least two ongoing right now. And there is some geopolitics around the relationship between, of course, the US and China. And that everything is becoming much more complex. Now, we see, of course, a regionalization of the supply. So in the past, the semiconductor industry, and even now, is a very, very global industry. We build equipment in US or in the Netherlands or in Japan. We ship this equipment to Taiwan or Korea or China. They build the products and then they get packaged in Thailand or in Vietnam or Malaysia. They get integrated in Southeast Asia or in China, and then you get the smartphone in Silicon Valley.
Yeah.
So very global. But now people are saying, okay, probably I should be paying more attention where these semiconductor devices are built.
Yeah.
And there is a race right now to get pretty much more and more funding and more scrutiny where the semiconductor devices are built.
Mm-hmm.
And for that kind of reason, of course, there are limitations because now we have some more regulation in terms of which equipment, for example, can be shipped to which region from which region. So, in other words, the 100% globality of the semiconductor footprint has become more limited in the last 3-5 years because of the importance of the semiconductor device itself, also because of geopolitical tension between countries. On the flip side, now there is more capital that is going to be deployed to make semiconductor industry in every single region of the world.
Mm-hmm.
And now, for example, we see after decades that US is investing in building semiconductor fabs, while in the past we were designing chips, so we were building equipment, and all the semiconductor devices were produced in Asia because of cost reasons. Now we see European Union more interested in giving capital to build the semiconductor wafer fabs in Europe as well.
It's going to be more expensive, I imagine, to produce in the US or Europe than in where it's being produced now. So does that mean that prices will go up because you're going to start applying this premium because the uncertainty of building it somewhere where you might not have to get supply and that'll even out, or the US and Europe continue subsidizing so that their production is competitive? I kind of imagine that if I am a software provider for healthcare and I'm thinking about what type of hardware I'm going to commit to, what I should be doing, I should be thinking about the foundational technology to put an expectation that I might face an issue in the future. But with modularity, if I could just switch out the semiconductor pieces that go into the hardware, so is there a movement towards modularity?
Well, it's an interesting point. First of all, whatever is happening in US or Europe, where we see more regionalization of semiconductor manufacturing, is not modular. So these semiconductor fabs are supposed to build the GPU, the graphic processor units. The modularity is a different aspect. So when I said before, the semiconductor technology roadmap advanced in the last 60 years. But there is something that, because you said modularity, that is happening right now with the semiconductor technology roadmap. And this is a little bit more technical. I hope I can explain very, very easily.
Yeah, let's assume that many of the listeners like me are not technically sophisticated enough to understand.
10 years ago, we wanted to build what we call the system on a chip. That means we have a chip, a semiconductor device, that has multiple functions. Then we figure it out and say, okay, if I have a core central processing unit that needs to be very, very, very advanced. But then in the same chip, I also have some logic devices to control the functionality of this CPU. Or I have memories embedded in my chip. I have multiple functions, but I was building together in the fabrication of the wafer at the highest possible technology because the CPU or the GPU was driving the technology node also for these peripheral functions that don't need to be built at this technology. So what the semiconductor industry did in the last few years, they decided to disaggregate this concept. And they said, okay, I can build a chip that is only GPU. I can build a chip that is a memory. I can build a chip that is a peripheral logic. And I build a technology node that is more convenient for me in terms of performance versus cost to build.
Yep.
So, and then I get all this chip and I aggregate this chip in the so-called wafer level packaging facilities. And this is a concept that technically we call heterogeneous integration of integration of chiplets. And this is what is happening. Now, it has nothing to do with the intent of the government to build a wafer fab, because in the wafer fab, you got to build GPU. But in the way how the final semiconductor device is built right now, is built with more modularity in place.
Yeah, I remember during COVID, we had this shortage of automobiles, and then I just remember hearing how many different chips are in just an automobile, and that was surprising to me. That's sort of what I'm visualizing.
Of course, you can have a chip in automobile. Let's get the example of automobile. As I said, let's assume we have an electrical vehicle. So there are so many different chips out there. Of course, the most advanced chips in an EV car is the one that is driving the computing aspect. Then there are memories, because in order to compute, so you have memory in the car as well. That is incredible, is beyond my imagination 25 years ago. And then you have sensors, and you have a camera, you have everything.
Yeah. Each camera has a chip, I'm sure.
Exactly. You have diversified number of chips that goes into electrical vehicle with autonomous capability car.
Okay. I have so many more questions, but we're reaching the top of our time with you. I guess my summary is like, we're building all this really cool front end stuff on these layers and layers and layers, and we are not aware of the fact that we're building on a foundation that is moving and shifting and compressing and diversifying. And so it's really important that any leader, whether you're in software or hardware or services, that you are aware of this. So thank you for helping us understand that it's not exactly a pyramid, but that stack. This industry has changed so much in the 30 years you've been there, and you have been working on strategy in operations. You've led huge organizations. What's the key lesson or some key lessons that a strategist or CEO should be aware of?
Yeah, definitely. I saw a lot. The industry moved a lot in the last 30 plus years. But there are things that I believe they stick forever, and they can be applied to different industries, not only semiconductors. What I learned, especially driving the strategic planning for the company in the many, many years, is that there are pillars of the strategy that are absolutely important not to trade off. And when I see these pillars, I would say three words: collaboration, innovation, and execution. When I see the most successful companies in the semiconductor industry, in the tech space, but I believe in any space, you need to have a collaboration effort in your ecosystem. And when I say collaboration, it doesn't mean a collaboration with your customer only. So you need to collaborate with your customer. You cannot come up with this incredible piece of equipment or semiconductor device if there is no collaboration inside the ecosystem between the supplier and customer. You need to collaborate with the customer's customers. And this is a concept that I pioneered when I was working in KLA. And the way how we see the industry evolving is more and more complex the device that we would like to build up, and more you need multiple levels of collaboration. And when you think about it, who is, for example, the NVIDIA of the world, or Amazon, or Apple, and so on, they design a lot of their own chips. And they know what kind of technology requirements they will need in the next 5 years. I'm 2 layers down in terms of equipment supplier, but I need to know what I need to build for the next 5 or 10 years, because as I said, the capital that these companies are going to commit and the time that you need to build these incredible products is very, very long. And for that kind of business, it's very important to collaborate with the entire ecosystem, with your customer, with your suppliers, because you build a very complicated equipment that needs a very, very specialized part of equipment that you need to collaborate with suppliers. So collaboration is number one. Then you have innovation, of course. I mean, without innovation in the tech space, but now everything is tech. So either if you are a software company, if you are a hardware company, retailer company, an industrial company, or semiconductor, you need to commit to innovation. You need to be incredibly open to continuously changing your perspective of what is needed in the market in order to make sure that you progress and you maintain your leadership in the market.
Yeah.
The point one is execution. And this is incredibly important because think about it, that you are producing incredible good products, but you cannot execute. You cannot ship your products when TSMC tells Samsung Michael need, or TSMC cannot ship the chips to NVIDIA whenever they need. It's a chain of execution that gotta work as a Swiss clock with incredible precision, accuracy, and predictability. So these are the three words that I believe every strategist needs to consider in whenever you do a plan, or you need to do a strategy, or you want to pretty much to communicate the strategy in your corporations: collaboration, innovation, execution. You cannot trade this off.
Yeah, I love it. I love it. Thank you. And what I also hear in that collaboration is that you've grown up in an industry in which the ecosystem and the moving pieces of the ecosystem require you to really think about strategy at the system level. And I think increasingly every company is going to have to start waking up to that their future really depends on the ecosystem system. Thank you for bringing that into the Trinity and for sharing some of your experience with us, Oreste. It was really great having you on, and I wish we had more time with you. Thank you for being here.
Thank you very much for inviting me, Kai. I'm really, really happy to be here. Thank you.
Thank you to our guest, Oreste Donzella, former Chief Strategy Officer of KLA, for an insightful conversation. Thanks to all of our listeners who follow the show. If you haven't already, please rate and comment on the show wherever you listen to this podcast. If you're an executive strategist who wants to learn more about Outthinker's network of Chief Strategy Officers, visit us at outthinker.com.